Boreas really started from two perspectives. First of all, I would say there's a sort of historical perspective about it. Britain has always had a very strong role in polar exploration. And if you look back at the history of polar exploration on the Earth, in fact, not just British exploration, but polar exploration in general, and ask yourself the question, where does all this go in the future? Really, the only planet that has substantial polar ice caps that could potentially play host to a long-term program of human polar exploration are the Martian polar ice caps. So it seemed logical to think about designing a station for the Martian North Geographical Pole as a place where you could launch expeditions across the Martian polar ice caps, where you could carry out studies of the geophysics and the astrobiology and the geological polar environment of Mars, and maybe even compare it to the Earth. But there's another recognition as well, and that's that most environments in the solar system of any interest for human exploration are essentially freezing wastelands. It doesn't matter whether, even if you're on the moon, it's essentially a freezing wasteland. There's not much ice there, but certainly in the permanently shadowed craters of the lunar poles, there might be some ice there. But even accepting a lack of ice, it's still a cold, essentially forbidding polar-like environment, dusty, not a lot of liquid water. And anywhere else that's of interest, for example, Europa, the surface of Enceladus, and potentially asteroids and comets beyond the outer edges of the planetary orbits of our solar system, where humans might one day go in the far future, are icy, frozen polar environments. And so if you start to develop an understanding of how to live and work in the Martian polar environment, you're essentially answering the question, how do I live in an extreme extraterrestrial polar environment where even the atmosphere I breathe has to be manufactured? And you can take those lessons and extrapolate them to other planetary bodies in the solar system. So those were the two things that motivated the study. And I won't hide it, that there was also a personal interest in the fact that I have a great deal of interest in polar exploration generally. I sort of have a hankering to have been a Martian Captain Scott. What could we do in terms of crossing the Martian polar ice caps in the future? And a Martian polar station would be the place from which you could launch out on expeditions across the Martian North Pole. The Antarctic and the Martian poles are very different environments. The Antarctic, for example, the minimum temperature that's ever been recorded there is minus 89 degrees centigrade, whereas in the Martian North Pole, temperatures can get down to about minus 140. So it's a much colder environment. And because of the low atmospheric pressure, the atmospheric pressure on Mars is about 1/100th of the atmospheric pressure on the Earth, water sublimates, or ice sublimates. It transforms from solid ice into gaseous atmospheric water without turning into liquid water in between. Whereas in Antarctica, when ice melts, it generally turns into liquid water. However, there are great similarities. These are environments where it's essentially a white landscape. It's very forbidding. It's psychologically very isolating to be in the Martian North Pole and isolating to be at the Earth's polar regions as well. So from a human point of view, there are psychological similarities in both of these environments. Very difficult environments to live in and survive. It takes a great deal of human effort to grow food, to make a living there. There are potentially exploratory similarities as well. You can imagine great expeditions across the Martian North and polar ice caps, or the southern polar ice cap, in the same way that explorers crossed the Antarctic and the Arctic on the Earth. You can imagine people striking out on unsupported expeditions across the Martian polar ice caps, great feats. The first transpolar expedition to cross the Martian North Polar Cap unsupported. These things have historical parallels with the polar exploration of the Earth. It's very difficult to set up a base at the Martian pole. I mean, there's two ways you can do it. You can land a base on Mars as one of the first projects that you do on the surface of Mars. So in some sense, think of it as like any Mars mission, where you build a station, you launch it to Mars, and you land it at the pole. That's a very challenging thing to do because the Martian polar ice caps are very cold. It's very difficult to make a living there. It's very difficult to grow food. So perhaps a more realistic trajectory for Martian polar exploration is that you would build a base at a lower latitude on Mars, where it's forgiving in terms of the physical environment. And then at some later stage of Martian exploration, you would then branch out and build a base at the Martian North Pole at some later stage of Martian exploration. You can gain an enormous amount of the resources you need from the surface of Mars. In fact, you can get everything that you need to live on the surface of Mars. The polar environment is a particularly good environment because, of course, you've got water ice, which you can simply melt and get liquid water from. It needs to be filtered and cleaned, but you can get liquid water, and then you can electrolyze that and get hydrogen that you can mix with carbon dioxide from the atmosphere, and you can make methane with a Sabatier process that you can use as a fuel for burning in rovers for locomotion or for mundane things like even cooking food. So the liquid water is very key. There are other resources you can get, of course, from Martian rocks. It becomes a little bit more of a problem at the Martian North Geographic Pole. In fact, that's one reason why living at the edges of the Martian pole might be preferential in the early stages if you're thinking about creating a long-term human presence at the poles. So you can get access to rocks you can break up and get essential elements from for industrial processes. And I think, again, going back to the point I made earlier, this is why we envisaged a station at the Martian North Pole as perhaps being a later development, because you could get your water resource quite easily and make fuel and energy from it. You can't do things like have a steel production works or make iron so easily in such a location where it's difficult to get access to rocks. But certainly in terms of resources for temporary inhabitation of a polar station, liquid water for growing crops and for human needs, the North Polar region is a good place to be. We imagined a station with 6 people who would be living in a module with 7 sections that did various different things. We had a central module where there was the ability to grow plants and carry out some greenhouse activities. It's well known that there's a psychological advantage to growing things in the space environment. It provides a distraction from the extremity of the environment. So we had a greenhouse module that might also provide some food. We had dormitory modules. We had a science module in which scientists would bring back ice samples or rock samples from their expeditions across the Martian polar ice cap and study them in the laboratory, look at the geochemistry, study the geophysics, look for traces of life, look at the organics. We also had another module that had the life support systems that were fundamentally a physical chemical life support system with possibly some biological life support system there as well. These modules were inflatable. We imagined this as a station that would land in sections and you would essentially inflate it at the Martian North Pole. And when I say inflatable, it's important to realize that these were multiple layered modules that would be able to survive the rigorous conditions at the Martian North Polar ice caps. There's not a flimsy construction at all, but the inflatability makes it easier to launch this thing either from a lower latitude Martian base or to send it from the Earth in sections and build it on the Martian polar surface. We imagined water around the outside of the structure that would be injected into the system using melted polar ice that would protect against radiation. So solar particle events are a problem for the crew, and one way in which you could do that is injecting water around the outside of the structure. That would also provide it with a bit more robustness as well. They were connected up, they were powered by solar panels, although we also had the possibility of nuclear power as well, using nuclear generators to generate power, partly because of the polar winter, of course, where you don't have solar power, and because it's a very energy-rich form of driving a station. There should be no doubt that a North Polar station will be an energy-intensive operation. You will have to create a lot of heat energy to keep the place warm during the intense cold of polar winter. You're going to need a lot of energy to melt polar ice, particularly in winter, when it's very cold. You will need a lot of energy to generate things like methane to run your rovers. This is not going to be an easy place to live. And so an energy production process that can deliver a large energy flux to your station year-round is going to be necessary at a polar station, and a nuclear reactor is a good way to do that. These 7 sections were on stilts. They were on stilts that essentially had wheels so you could move them around. We didn't envisage the base moving too far, but you could certainly, in the local area, move these modules around and readjust them. They were built on stilts because the Martian poles experience carbon dioxide snow during the winter. In fact, at the Martian North Pole, there's about 2 meters of carbon dioxide snow that builds up underneath the station. You can get rid of it quite easily. Unlike the terrestrial poles, when you have a build-up of snow, it's quite difficult to get rid of that. It very rapidly freezes and becomes very compact, and you can try and shovel it away with bulldozers. But in fact, the problem of polar stations disappearing into the ice in Antarctica is well known, and one of the ways you get around this is by putting them on jacks. You can jack up the station as time goes on and snow accumulates. It's not really like that in the Martian North Pole, because the carbon dioxide snow is easy to get rid of. You can just warm it up and it sublimates away and disappears into the atmosphere. So we had these mats around the station that you could heat up and sublimate the carbon dioxide snow as it landed, so you'd always have a clear area around your station. But nevertheless, we still decided to have the station on stilts to provide some redundancy. If those mats fail, you don't want 2 meters of Martian carbon dioxide snow covering your station. So we had these on stilts, and that would allow for the carbon dioxide snow to settle and give you time to get rid of it, but also provide you with some redundancy as well. We imagined these explorers would go out from station and carry out a very wide-ranging and ambitious exploration program. And we split up this exploration program into several phases. The first phase would be forays into the very local area as they develop experience in that particular area around the North Pole. Of course, they may have information even before they built the station from remote sensing, possibly robotic landers. But even so, once you've built the station, you want to get to know the area around it and get familiarity with the technology that you're using. The exploration program would then expand, and they would use pressurized rovers and unpressurized rovers to go out further into the field, exploring further away until they get to the Chasma Boreal, which is almost like a canyon valley system in the ice. Eventually, in the final phase of exploration, they would travel out right to the very edges of the Martian polar ice cap and carry out the complete exploration of the polar ice cap over summer. We even envisaged them having midwinter expeditions in the dark, and you can see this picture of the Martian North Polar Station with its lights on, with the carbon dioxide snow fluttering down, these explorers coming back on their snowshoes or skis across the Martian North Polar ice cap with the carbon dioxide snow coming down, almost like a Christmas scene at the Martian North Pole as they come back in the middle of the dark. There's 2 reasons for these expeditions. One is scientific, to collect samples, to carry out an ambitious and very detailed study of the Martian North Polar ice cap. We wanted them to drill into the ice cap and study these well-known layers of ice that make up the ice cap, looking in those ice layers for ancient dust storms on Mars, to try and map the history of them, to look for pieces of impact rock from asteroid impacts in the surface of Mars in the past, and try and develop an understanding of impacts over the last few million years by drilling through these layers of ice, and to look for signs of past life, or to study the organics in these ice layers and understand what role the Martian polar ice caps have played in the past climate of the Earth and habitability of Mars as an abode for life. But also just because they're really exciting places to carry out expeditions. The midwinter expedition had very little scientific value apart from perhaps studying the carbon dioxide snow, but in fact you could put out robotic stations across the ice cap to collect snow and study it. But they need something exciting to do, and if they're going to be at Martian North Pole Station, they want to go out across the polar ice cap and carry out expeditions purely for the exploratory sake as well. So the midwinter expeditions were just exciting polar expeditions across the Martian North Polar ice cap. One of the problems with working on Mars is the large amount of dust which gets picked up from the surface. Dust is a problem everywhere on Mars. It's perhaps less of a problem at the poles because there's not a uniform layer of dust covering the Martian polar ice cap, but it is in the layers of ice within the polar ice cap, and it will very quickly get released from the surface during the summer as the ice sublimes. So we have to figure out a way of reducing the amount of dust that gets into the North Polar Station. So we had a German group who came up with a very novel solution, which was to have suits that would dock on the outside of Polar Station and also on the outside of the rovers. This allows the base occupants to climb into their suits inside the station and essentially disconnect themselves from the station and then walk out across the pole, or reconnect themselves with the rover and get into the rover and drive across the Martian polar ice cap. So the suits were docked with the station and also the rovers. There are major psychological problems with living in a station, particularly the Martian North Polar, geographic North Pole. The obliquity, or the tilt of Mars, is very similar to the Earth. And this means that the polar ice caps, like the Earth's ice caps, experience long periods of complete darkness. Now, the Martian year, just over 680 days long, means that the period of darkness at the Martian North Pole is just under an entire Earth year. It's about 340 days of complete darkness. This is a very extreme environment for human beings to be living in. It's difficult enough to survive 6 months of darkness in Antarctica or in the Arctic on the Earth. So they would have to try and overcome this by developing probably connections with the outside world. This could happen electronically with other stations on Mars, or perhaps even with people on the Earth. Now, this raises a question, of course, of how long you would leave them at the polar station. In our study, we assumed they would be there for 2 Martian years. In other words, that would be equivalent of essentially 3 Martian summers and 2 polar overwinterings. And it's another reason why it would be unlikely that you would build a North Polar Station in the earliest stages of Martian polar exploration, because if you want to establish a permanent human presence on Mars, what you want is people staying on Mars for a long time and building a station. If they're going to go crazy after 2 years at the Martian North Pole and have to tolerate almost a year of complete darkness, this is not a good place to start building a permanent presence. So you could imagine a station at lower latitudes where people were sent up to the Martian North Pole to spend a year or 2 years. They would go and do research there, and then they would come back to a lower latitude station where you have more normal psychological environment. There's little doubt in saying that a Martian polar station is an extreme environment, and it will impose polar overwintering conditions on people that have never been seen in any polar station on the surface of the Earth. We did have a discussion about some of the psychology. In fact, there was a chapter in the Project Boreas report that addresses the particular mixes of people that you might take based on what we know about the psychology of terrestrial polar stations. Despite decades of studies on the psychology of people in polar stations, I don't think anyone has really come up with a definitive answer to the best people to send to these stations. Some people say that you should send an odd number of people so that when there's a split in the group, you always have a majority, which is a nice idea, but of course if someone abstains, then you've still got the same problems. It's clear that the mix of sex it can be an issue. I think that a 50-50 mix is a good thing. There have been disasters where you have polar stations on the Earth where it's a majority male station and you have just one woman, particularly overwintering. It sounds a rather trite and trivial observation, but this has actually caused major problems when people have been in very isolated environments. My experience in polar environments, and I've been to Antarctic and Arctic environments, is at the end of the day, it's just about picking mature, professional human beings who can live in those environments, overcome their differences, and focus on the mission at hand, and dealing with the inevitable interpersonal problems that will come from living in an extreme environment where you're going to be spending almost a complete year in darkness. One of the things that we did want to do was to have these people supported by robots to explore the Martian North Pole. They can't go out and do everything themselves. And we were trying to think up, I was working with Alex Ellery, trying to think about, he's a roboticist, but how we could build a series of robots for the Martian North Pole. And I sort of drew on my experience of the Arctic and having been up to the Canadian high Arctic a few times and seen the wildlife there. And it occurred to me that you could actually build a whole series of robots that exactly mirrored the wildlife in the Arctic. So we had a robot called Arctic Fox, which was the largest robot that went across the Martian North Pole and took photographs and took measurements and collected samples, and would just wander around the North Polar ice cap throughout the summer and the polar winter, studying the surface. We then had a robot called Arctic Hare, which bounced around the surface. This was a smaller thing. It was much better at surviving during the winter when there was carbon dioxide snow, and it bounced around like a hare. And as it bounced and landed on the surface, it would have little penetrators that would go into the subsurface and take samples. And then we had a whole swarm of mini robots called the lemmings. And the lemmings were about this size, and they had little legs, and they would run across the Martian North Polar ice cap, and then they would fold their legs up into the lemming and become like little moles. And their noses were essentially melting devices that would sublimate the ice and carbon dioxide snow, and they would start to bury their way into the Martian polar ices and burrow their way through the layers of ice at the Martian pole, taking measurements as they went through. So they have a mini Raman spectrometer, maybe a near-infrared spectrometer, and melt their way through the ice caps. And you would send out hundreds of these lemmings, and they would also go on destructive missions like real lemmings. They would go to the edge of the Chasma Boreal, take some measurements, and then little atmospheric sensor would flip out and they would hurl themselves over the cliff. The Chasma Boreal, taking measurements of the polar atmosphere as they went down into the Chasma Boreal, and then, obliterate at the bottom, hopefully in a sort of environmentally non-messy way. We weren't quite sure how we would do that, but presumably they could, they would land and then not break apart or freeze or something. So that the lemmings were the little robots, and they could also jump out of the fox and explore. And we also had a snow bunting, which would be a robotic aircraft to fly across the Martian North Polar ice cap and take remote sensing images, measure the atmospheric composition over the Martian Polar ice cap, measure the temperature gradient above the Martian Polar ice cap as well. And these robots would all be interconnected with the station, and the explorers would sit in the station during the winter and summer with their robotic modules and control this suite of Martian robotic wildlife that they would control across the Martian North Polar ice cap.